Okay, let's look at example 12.13. They got a motorcycle jump. It's at an angle of 30 degrees and the jump is 1 meter off the ground at its peak. And apparently it was observed that the rider remains in the air for a total of 1.5 seconds. Excuse me. Determine the speed at which he's traveling, v naught, off the ramp. We know the direction it came off of, but we don't know the magnitude. And find the horizontal distance he travels and the maximum height attained. And we're just going to neglect the size of the rider and the bike for right now. Basically, this is a point mass with some vector. And first thing first, I'm going to break that vector up into components. So we're going to have a v sub x and a v sub y, where the v sub x is going to be equal to v naught cosine theta, and vy is equal to v naught sine theta, where this is theta and our theta is equal to 30 degrees in this case. Okay, so we can find the velocity by taking a kinematic equation. Y final is equal to y naught plus v naught in the y direction. That's this thing. Plus 1/2 gt squared. We're dealing in the y direction, so we need to worry about gravity. So I'm not going to cancel any terms. All of the terms exist. Go ahead and plug in the v naught sine theta right here. There needs to be a times time. Times time plus 1/2 gt squared. Alright, now what do we not know? We know, the only thing we don't know is v naught. We know that y final, if we call this right here the origin, like I did in the problem previously, that puts its initial position at 1 and its final position at 0. Then we have v naught times the sine of 30 degrees. That is equal to 1/2. So we're going to use some unit circle stuff quite a bit. Make sure that you know that the sine is the y coordinate and the cosine is the x coordinate. It goes 1, 0, square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, and then they flip 1/2 square root of 3 over 2. If you can remember this quadrant, then you can do this quadrant, this quadrant, and this quadrant by flipping the signs. But I highly recommend learning this, or you know it, just be able to do that at the top of your head. We typically work with nice round angles like 30, or in this case was pi over 6, right? Okay, so here we go. We know the time also was 1.5 seconds. And we have gravity as negative 9.81 meters per second squared. And once again, 1.5 seconds. So the only thing we don't know is v naught, and that is the magnitude. So the magnitude that it is launched with is 13.4 meters per second. Alright, that was one of the things they asked for. That's the speed. The vector would be 13.4 meters per second at an angle of 30 degrees. We need the magnitude and the direction. Okay, now we can do the height final, or doesn't matter. Let's get numbers for this v sub x and v sub y. V sub x is v naught, cosine 30, and it's about 11.6 meters per second. Vy is equal to v naught sine 30, and that's about 6.7 meters per second. Let's find the range right now. The range would be the whole horizontal distance traveled, delta x. How far did it make it, and where did it strike on the ground? So to do so, I'm going to use x final is equal to x initial plus v naught times time, and that's in the x direction, plus 1/2 acceleration times time squared. We have no acceleration in the x direction, and we know our v naught now. We can calculate it. If we started at 0, we can cross out x initial, and we just get x final, or the range being equal to the 11.6 meters per second times 1.5 seconds, the flight time. And we get 17.4 meters. Alright, and the one other thing it asked for was the maximum height attained, so it's going to level out and hit some place where the velocity in the y direction is going to go to 0, and we're going to use that fact. So we're going to use the fact that the velocity in the y direction is going to go to 0. So Vf squared is equal to V initial squared, or V naught, plus 2 times gravity times delta y. If it goes, physics tells us it goes to a 0 velocity in the y direction at the top, so let's go ahead and find out the distance it takes to make that happen. We know v naught, so we can say 6.7 squared plus 2 times negative 9.81, and then solve for delta y. For delta y, we need to use the fact that we started 1 meter lower, so I'm going to plug in a HF minus 1 right there. And then after you solve all that, you can get an HF equal to 3.28 meters. Alright, that's how high it went. It traveled 17.4 meters to the right, and to do all that, it had a velocity of 13.4 meters per second at 30 degrees.